Today's lesson is solving quadratic equations by factoring. We've already looked at solving quadratic equations by graphing, and just wanted to show you this just to connect what we did a couple of sections ago and how does that compare to what we're going to do today. This is actually one of your homework problems from the 3-2 skills practice sheet, where you had to find the solution to that blue quadratic equation at the top of the screen, and your instructions were to find the solutions by graphing. And we talked about how that the solution when we're looking at a graph to a quadratic is, if there is a solution, it'll be where the graph crosses the x-axis, or in other words the x-intercepts. We also call these zeros of the function. So it's obvious to see from the graph that our solutions are 1 and 5. Well, let's take a look at a little preview of what we're going to do today. Hopefully you remember from Algebra 1 how to take a quadratic trinomial like this and factor it as two linear binomials. Now, what I mean by linear, I mean that we're going to have x to the first power in each binomial. That makes it a linear term. And of course, binomial means two terms. So the factored form, and we're going to look at a refresher on how we get this in just a moment. The factored form of the blue trinomial is the multiplication of these two red binomials. And it's from the factored form that it makes it easy to find solutions. The solution, the number that I would plug in for x in this first binomial would be 5. If I do, I let 5 go in for x, I get 0, and if I let 5 go in for x here, I get 4, but 0 times 4 is still 0. My solution that comes out of this binomial will be x equals 1, because if I let both of these x's become 1, I get 0 here, I'll get negative 4 over here, but 0 times negative 4 is still 0. So I got the two solutions just like we did with graphing, just using a different method, and that's going to be the emphasis of today's lesson. Alright, so first of all, what is factoring? We need to make sure that you understand not just the mechanics of what you're going to be doing, but what is it? Well, here is a pretty simple definition. We can rewrite expressions using multiplication. And let me give you an example. Please pay attention to my key point here. When you're factoring, the first thing that should always come to your mind in factoring is to look for what we call the greatest common factor. And I'm sure you covered this in Algebra 1. Maybe just looking at a few examples, it'll bring it all back to you. But the GCF for letter A is 3. 3 is the largest number that divides into 3 and 9. 3 then serves as one of the factors. Remember, I'm about to write this as the multiplication of two factors. Well, 3 is 1. We call it the greatest common factor. The way I get the other factor that I'm going to write in the parentheses is I'm going to divide 3 into each one of these terms in blue. When I divide 3a squared by 3, I get a squared. And when I divide 9 by 3, I get 3. So a simple check using the distributive property shows that this, when multiplied together, does equal the original blue expression. And that's again what factoring is. Another way of writing an expression using multiplication. Okay, letter B. I'm looking for a GCF. I notice that both of these terms have x in common. X is my GCF. That is a factor. Alright, what is the other factor? Well, to get that other factor, I'm going to divide x into both of these blue terms. When I divide x squared by x, I get x. When I divide 2x by x, I get 2. And the great thing about factoring is it's very easy to check. I can just do some mental math here, distributing x to both of these. I get x squared, and I get minus 2x. This is another way of writing the blue expression, also called factoring. Okay, one more. The GCF for these two terms will be 7y. That is one of my factors. The other factor will be what I get when I divide 7y into both of these individually. So when I divide 7y into 14y squared, I get 2y. When I divide 7y into itself, I get 1. Any number divided by itself is just 1. So quick check. If you wrote something down, multiply it together, and it does not come up to this, then you know you've done the factoring incorrectly. So you can always check your factoring. There's really no excuse to miss a factoring problem because you can tell if it's right just by doing some either distributive property, or in some cases you'll use the FOIL method. Okay, so moving right along, now that you've gotten a little taste of factoring, let's just continue on with some other examples. We're still looking for a GCF in letter D, but I don't see one. My coefficients are 1, -12, and 32. We don't consider 1 when we're thinking of a GCF in this case. So they all don't have a common variable, so the bottom line is there is no greatest common factor among these three terms. So my next step will be, my next best thing in factoring will be seeing if I can factor these out as two linear binomials multiplied together. Okay, again, linear means that each of these groups should have x to the first. A linear term means x to the first power. From Algebra 1, I hope you learned that whenever your trinomial is set up as minus in front of plus, then that tells you your factoring is going to have two minus signs. That's always true. So now, the way I'm going to get these other terms that go in the parentheses is I'm going to think of the factors of 32 that add up to 12. Now you might think, well, isn't it -12? Well, yeah, I've already taken care of the negative signs. I know these have to be negative. So just to make it easy on yourself, just think of the factors of 32 that add up to 12. And I hope you realize that those are 8 and 4. 8 times 4 is 32. That's the coming up with the last term. 8 plus 4 is 12. That's the middle term. So that tells me I got the right combination of numbers. And again, if you want to make sure you're right, you can use FOIL on the red and it should come back to the blue. Okay, let's take a look at letter E. This time I'm looking for the factors of negative. Well, first of all, I'm looking for a GCF. Don't see one. So I'm going to try to factor this as two linear binomials multiplied together. So this time I'm looking for the factors of -21, and those same two factors when added together should add up to -4. Well, there's not a whole lot of choices for -21. Let me just give you a list. These are factors of -21, but when I add these together I'm not going to get -4. I also can do this. I could do 7 times -3 or -7 times +3. Those are factors of -21, and this pair when added together would also equal -4. So I've circled the pair of factors that will be used in this factoring. So remember, x to the first in both groups, and one group will have -7 and the other group will have +3. And again, no excuse for missing these. FOIL would just take a few seconds and you can double check and make sure that you did the right thing. Alright, letter F, I do see a GCF. I see that 2 is the largest number that will divide into 2, 24, and 72. So let's factor out the GCF first. And again, that's a factor, and the way I get the other factor that will multiply times 2 is I'm going to divide the GCF into each one of these terms. So when I divide 2 into 2x squared, I get x squared. Minus, when I do 2 into 24x, I get 12x. Plus, and 2 into 72 is 36. Okay, now I'm going to see if it's possible to factor more using the product of two linear binomials multiplied together. See if it comes up to this trinomial in the parentheses. So linear binomials, I need an x in each group. Once again, just like our letter D, I have minus in front of plus, and so the minus signs are going to be in both. Now I just need the factors of 36 that adds up to 12, and it would be 6 times 6. 6 times 6 is 36, 6 plus 6 is 12. You may have also recognized this as a perfect square trinomial, and you could have also written it as that. Okay, let's keep on going. Here's a special case that I just wanted to refresh your memory on. Letter G. This is called a difference between two perfect squares. And these are nice. These are easy to factor if you recognize them. First of all, they're going to be a binomial instead of a trinomial. So whenever you have two terms, only two terms that you're trying to factor, and especially when they're being subtracted, you should think about this special case. It's still going to be two linear binomials multiplied together. So I'm going to have x to the first in each. But these factor really well because all I need to write in the groups is the square root of 36. The square root of 36 is 6. See how I just wrote that 6 in both groups? Now, one of these groups will need to be plus, and the other one will need to be minus. And that is how you factor this special case called the difference between two squares. Here's another one, just real fast. X squared minus 64. Well, if you recognize that is two perfect square terms, they have perfect square roots. They're being subtracted. So the factoring would look like this. X plus 8, that's the square root of 64, times x minus 8. Very easy to do. Okay, letter H. Don't see a GCF, so my next best thing is to try to factor this as two linear binomials. So this time I'm looking for the factors of 14 that would add up to 9. And I hope you're maybe going through the list. 14 times 1, those are factors of 14, but they don't add up to 9. So my only other option will be 2 and 7. Those are factors of 14, and they also, when added together, would add to 9. And there's no magic to the order here. You could have had 2 here and 7 here. So there's the factoring. Okay, letter I, in Algebra 1, we would have said, well, we could factor out a GCF, and that would have been the end of it, because we weren't exposed to the number I. Well, now we can factor the sum of two squares, but it's going to take the number I to do it. Okay, so hopefully you see the first step I took is to factor out the GCF. So here are my two factors. If I do the distributive property with 4, I'm going to get the blue. This is a rewriting of the blue expression using factors. Okay, well now let's think about how we can factor this sum of two squares. Alright, it's kind of like what we did up here with the square roots. But if I just leave it like this, if I did FOIL on this, I'm going to get x squared minus 4. Do you see that? And obviously I need to come up with x squared plus 4. Well, this is where the number I is going to come in. What if we do this? Now when it comes to doing that last term, you know the outer and the inner terms are just going to cancel. Okay, so that last term is going to be found by doing 2 times 2, which is 4, and then you got I squared. Well, do you remember what I squared is equal to? It's negative 1. So it's like saying x squared minus 4 times negative 1, and negative 4 times negative 1 is plus 4. Okay, so this is how we ended up factoring this sum of two perfect squares utilizing the number I. And when you get to number 33, if you'll look back on this problem, it's a lot like it, okay, when you get to your homework problem. Okay, now I want to show you a factoring method that I want you to learn, and on your next test you're going to be required to show it. And it's only used when we have quadratic trinomials, 3 terms, and not only that, but when this first term, the number in front of x squared, is bigger than 1. Okay, notice when we have a trinomial, quadratic trinomial, and this first term is 1, I don't want you to use the box method. It really takes longer to use it than it is just to come up with the factors of 14 that add up to 9. So don't use the box method in cases like this. But in cases like this, where you notice the number in front of x squared is greater than 1, here is the box method. I call it the box method. Maybe it has other names. The reason why is that we're going to make a box, and inside the box we're going to make 4 squares that will contain terms in just a moment. Well, right off the bat, in these diagonal squares, we're just going to list the first term of the trinomial, 6x squared, and then diagonally from that I'm going to write the last term. Okay, easy first step. My next step will be to multiply those together. What do I get when I multiply 6x squared times 4? I get 24x squared. Okay, now this next step is, once we get it, it'll be downhill. It'll be smooth sailing from here. We just need to come up with the factors of 24x squared, okay, 2 terms that multiply together to give me this, and those same 2 terms would add to give me this middle term 11x. Okay, for example, I could use 6x and 4x as factors. Those multiply to give me 24x squared, but they add to 10x. I need 11x, so those aren't going to work. What would work is this, 8x times 3x. Those are factors of 24x squared, and those 2 terms also add together to give me the middle of the given problem, the middle term. So those 2, when I find them, I'm going to write them in the other squares, and it doesn't matter where you place them. You can switch these up and you'll get the same answer. Okay, now I'm going to make some blanks, and we're just about done with this. We're going to find GCFs of these 2 rows and these 2 columns. Alright, so this top row, let's find the GCF, and I hope you can recognize it as 2x. For this bottom row, it's okay in using the box method. If 1 is the only GCF we have, then we can list it. There is no other number that divides into 3x and 4 besides 1. Okay, now let's go this way. Let's find the GCF of these 2 numbers. And I hope you recognize it as 3x. And going this way, the GCF would be 4. So these numbers that we have written on the sides and down below represent our factoring. One of my linear binomials is 2x plus 1. The other one is 3x plus 4. Okay, and just a quick FOIL check could be done, and you can see that we did the factoring correctly. Alright, so in the past, sometimes when we deal with this situation, we just try some things and see if they work. Some trial and error is involved. This is a more direct way of getting us to the final factoring, and I want you to learn this. You will have to show it on the next test. Okay, let's just try another example of the box method. So we'll go ahead and draw our box, do our squares. Once again, we've got that situation where we have in our trinomial, we have minus in front of plus. So in using the box method, I would suggest that in cases like this where the signs are already determined, we already know in the factoring what the signs are going to do, don't worry about putting signs in the box. just do all positives, and then when we come up with our GCFs, we'll just fill in these blanks. Okay, so to start off, 4x squared and 9, just take the first and the last terms, multiply those together. That's 36x squared. And now think of the factors of 36x squared that would add up to 15x. Okay? And I hope you're thinking 12x times 3x. Because not only do those multiply to this, if you added those together, you would get the middle. Again, don't worry about the negative. That's already been decided. Alright, so these two factors that we've come up with are going to fill in the other two squares, and the order doesn't matter for these. Okay, so let's find our 4 GCFs, and we will have the final answer. For this top row of factors, the GCF would be x. For this second row, the GCF would be 3. For this first column, the GCF would be 4x. And for this, the GCF is also 3. So our factoring is shown. 4x and 3, x and 3. Alright. So the more you do it, the easier it gets, and I do think it'll help you, especially when you move on to higher levels of math where the factoring gets a little more complicated. Okay, so we're now ready to solve some equations, and we're going to utilize factoring to make this possible. So this letter A problem, to start off with factoring, remember we always want to look for a GCF first. And I do have one. The GCF would be 8x, and that's a factor. The other factor, to multiply times 8x to give me this, hopefully you can see this, will be 2x plus 1. Okay, so the red represents the factored form of the blue. And the great thing about factoring is it makes it easy to find solutions, because I'm going to take each one of my factors separately, and I'm just going to make two little equations out of them. I'm going to let 8x equal 0. I'm going to let my other factor, 2x plus 1, equal 0. And I'm going to solve for x in each equation. So one of my solutions is x is 0. Solving this equation, 2x is equal to negative 1, so x is equal to negative 1/2. That is my other solution. Okay, that's the answer for letter A. Letter B, let's look for a GCF. Well, I see that 6 divides into 6 and 18. That's the largest number that will divide into both. I also see that I can take out a to the 4th. A to the 4th divides into itself and into a to the 5th. That is a factor. The other factor, after I divide, I will come up with a plus 3. So you want to make sure before you go on, did I do that factoring right? Well, let's do the distributive property. 6a to the 4th times a, 6a to the 5th. 6a to the 4th times 3, 18a to the 4th. I'm feeling good about the factoring, and now I just let each of my factors equal 0, and I solve for a in each case. So if I divide by 6, I get 0. If I do the 4th root of both sides, I still get 0. So we call this multiplicity. There's actually 4 different solutions coming out of this, but it just happens to be 0. Think of it used 4 different times. Over here, pretty easy. We just subtract 3 from both sides and we get our solution. A is negative 3. Alright, very good. Let's try letter C. For letter C, we're looking for GCF, but I don't see one. So let's try factoring 2 linear binomials. Or maybe you recognize that that's a perfect square trinomial, but if you don't, that's okay. We're going to set up 2 linear binomials, x to the 1st in both cases. The factors of 64 that add up to 16 are 8 times 8. Okay, so really we just have the same number that serves as a solution for actually both of these. So I guess you can see that if you set x plus 8 equal to 0, you're going to get the solution x equals negative 8. Okay, let's try letter D. There is a GCF. It's 9x. All right, the other factor will be 9x minus 1. We just divided the GCF into both of these. Okay, this is the factored form. Now let each of your factors equal 0 and solve each. All right, if I solve for x here, I get 0. 0 divided by 9. Over here, I'm going to add 1 to both sides. Then I'm going to divide by 9 on both sides. And I get x is 1/9. So those are my two solutions. Okay, so far so good. Let's try letter E. Well, we looked earlier at how we could factor this. There's two different ways of solving this. Maybe I'll just show the factoring. A plus 3i times a minus 3i. Okay, and so now we can set each of these equal to 0, solve for a. So we're going to get negative 3i and positive 3i. You could have also, although we're doing this by factoring, but this is what we did yesterday, just to make a connection, get the same thing this way. But since the whole emphasis of today's lesson is on factoring, I guess we'll stick with using this method, the factoring method. All right, what about letter F? Look for GCF. Don't see one. So is it possible to factor this as two linear binomials? Okay, let me make that straight. Let's see. Once again, same scenario. We got minus in both. So the factors of 30 that add up to 11 are 6 and 5. So just take each of your factors, make them equal 0, and solve for x. X is going to be 6. X is going to be 5. All right. I gave you this one kind of as a heads up. Whenever you see this a term is negative, you need to rewrite this so that it's positive. Okay, simple enough to do. Just think multiplying both sides of the equation by -1. And the result of that is going to be to change all of the signs. And 0 times -1 is still 0. Okay, now you're ready to do some factoring. And I notice that the a term, the number in front of x squared, is larger than 1. So I'm going to go to the box method for this one. Okay, it starts by putting the first and the last across from each other diagonally. Multiply those together. And if you do, you will get negative 180x squared. Okay, so the biggest challenge for most people in this method is finding the factors of this number, this term, that add up to the middle term, negative 8x. And the factors that add up to negative 8x would be negative 18x and positive 10x. Multiplied together, they would give us this. Added together, they would give us the middle. Now that we found those, we can put those in either square. Doesn't matter. Okay, now let's find our GCFs, and it'll take us to the answer. So the GCF for this first row of numbers is 6x. The GCF for the second row of numbers is 5. For this column of numbers, the GCF would be 2x. Now, in this case, if the two numbers are negative, that's going to make your GCF negative. That's the only time in this method that the GCF will be negative, and that's if the two numbers are negative. Okay, so it looks like we got our factoring, 6x plus 5 times 2x minus 3. So we just found another way of writing the original trinomial, but the factoring is going to make it really easy to come up with the solutions. So take each of your factors, make them equal 0, solve for x. One of your answers should be negative 5/6. Over here, if you do the same thing, 2x minus 3 is 0, 2x is 3, so x is 3/2. And those are our two solutions. But it took factoring, the factored form, to get us to that point. Okay? All right. We are doing good. I think we just have one more example to cover. And this is kind of, this is actually the first 3 problems in your homework, but I decided to put these last in your notes because I wanted to really give you a feel, get you back into the swing of the factoring process before we took a look at these. What's really happening here is it's like they're going to give you the answer and you've got to come up with the equation. It's kind of the reverse of what we were doing before. We were given an equation, we came up with the answer. Well, let me tell you how you can easily find the standard form equation, which I've written here for you, if you're given this solution. You're going to take basically 2 binomials. They're going to be linear binomials. They're each going to have minus. I'm going to give you a little template of what to do to work through these problems. Okay, so you can always start with what I've done here. All right, and now this is your starting point, and now just take the number that's given to you and plug it in. And again, since we're only given one solution, but it's a quadratic, it's as though that one solution was a 0 for 2 different linear binomials. It's the same number used as a 0 in both. Okay, you can think of it that way. Okay, well now let's use FOIL so that we can end up with our standard form linear equation. So using FOIL, we're going to get x squared minus 3x minus 3x plus 9 equals 0, and then combining like terms, we're going to get x squared minus 6x plus 9 equals 0. And that is your final answer. But it all starts with 2 binomials, both of them minus, and you just drop in the number that you're given. Okay, let's do letter B. All right, once again, you can just write this down. X minus, and now we're going to drop in the given numbers. We're given negative 3, and we're given positive 1/4. Well, we don't write x minus negative 3, do we? So can we just go ahead and change this to x plus 3? Maybe I'll just, so you don't have to erase your notes, I'll just write it below. X plus 3 times x minus 1/4. Okay, maybe I can squeeze in over here and not have to go to a new slide. So let's use FOIL. All right, so we got x squared minus 1/4 x plus 3x minus 3/4 equals 0. We need to combine like terms in the middle, so I'm just going to change 3 since this is in fourths. I'm going to make 3 become 12/4 x. Okay, and 12/4 minus 1/4 is 11/4 x. minus 3/4. Alright, now standard form should not contain fractions. It should only, these numbers a, b, and c should be integers. So that's pretty easy to take care of. If I just multiply really both sides of this equation by 4, that will clear out all the denominators. So multiplying by 4, I get 4x squared plus 11x minus 3 is equal to 0. And now I have my final answer. So your answer should be in standard, it's a standard form equation. So if it doesn't look like this, then maybe you've got some more work to do. And it all starts like I've shown you here. Just create two binomials. You're going to fill in the blanks, x minus, fill in the blank with the given number, and then use FOIL, and you can get to your final answer. Well, I hope that helps. If not, you're welcome to email me, or you can come by academic support and work hard on this and bring them back to class with any questions you may have, and we'll see you next time.